Osborne is right. Here is the reason why rogue waves occur in the deep ocean. It isn't to do with strange local conditions. It's because waves start to behave in a bizarre, non-linear fashion. For some reason, they become unstable and start sucking up energy from waves around them.
You have what's called a rogue sea. Now, mariners have known about this. You look at the sea state in one moment. Everything just looks random, boring waves that we've known about for a long time. But then, one of these waves will come up. They're all there. They're all hiding away. One of them will come up. Then a little later, another will come up. But in between, you won't see them necessarily.
Osborne's theory means that there are two types of wave: the ordinary stable linear wave and an unstable non-linear monster. A wave that at any point can turn into a rogue.
It says that there are really two kinds of waves. Amazing thing. Not the old boring sine waves that we've known about for 2 centuries. Not only those, but there's another kind of wave. It's a really special beast. It hides below the background waves and then comes up every once in a while.
This could then explain what Wolfram saw in the North Sea. It could explain what caused the waves that hit the Bremen and the Caledonian Star. And it could explain what caused the large number of waves observed by satellite. It seems that there is a separate population of waves out in the ocean that are higher and more frequent than anyone had thought possible. And there's something that makes these waves especially deadly. It's not just their size, it's their shape. The linear model used by the shipping industry has always assumed that waves are smooth and gently sloping. So ships are only designed to cope with undulating waves like these. But according to mariners, freak waves are very different.
It was a vertical wall. It wasn't a sloping wave. It was a vertical wall of solid green water.
I likened it to the White Cliffs of Dover. It just looked as though there was this enormous great cliff ahead of us.
Freak waves aren't the smooth, undulating waves ships are designed for. They are so steep, they can actually break. It means they can hit a ship with astonishing force.
The reason why rogue waves are so damaging is because they're breaking. It's no longer really a wave. It's just a pile of water coming flying at you, and it just goes bang.
Engineer Rod Rainey analyzes ship damage for the marine industry. He has been calculating the huge forces that these giant breaking waves have on ships compared to normal waves.
This ball here represents the force of a 3-meter classical linear wave hitting a ship. That's a force of about 1.5 tons a square meter. This represents a typical storm wave, say 12 meters high, hitting a ship. About 6 tons a square meter. And this represents a force from a rogue wave. That's about 100 tons a square meter.
This force is far greater than most ships are designed to withstand.
We've looked very carefully at ships that have been damaged by breaking waves, and we are sure that the pressures that you can get over substantial areas are about 100 tons a square meter. Now, that compares with what a ship is normally designed for, high up on the side, which is typically about 15. Now, just to be clear here, that 15 tons per square metre is what it can take without any damage at all. It can take perhaps double that if you allow it to dent, but it can't take 100 tons a square metre. That will hold it.
It seems that rogue waves are not only out there, but they are far more powerful than any ship can handle. All the scientific evidence suggests that the old explanation for why the shipping industry loses a ship a week may be inadequate. It may not be just corrosion or pilot error. Some, at least, must be due to freak waves. It means that at last we can lay to rest some of those mysterious disappearances at sea, like that of the München. As the storm grew on that fateful night in December 1978, the München would have carried confidently on, carving through the rising seas. Until suddenly, out of the darkness, there would have loomed a huge 30-meter wall of water.
The way it most probably goes is that the bow of the vessel is diving into a trough, a wave trough. And then before it has raised up again, the wave is, so to say, collapsing over the bow and the superstructure, and with tremendous force striking against the front bulkhead, hitting the starboard lifeboat and doing the damage which we have seen on the picture.
The wave would have smashed into the bridge, just like it did in the Bremen. Taking out the instruments and engines and rendering the ship helpless. If the ship had turned side on to the waves, another wave could have held her. Water would have poured in, eventually plunging the great ship München and everyone on her to the bottom of the sea.